So today we're gonna work this out. The equations are at the top. It says how many liters of carbon dioxide are made from 6.55 liters of methane at STP. So our equation was CH4 plus 2O2 yields CO2 plus 2H2O. Okay. So
Oh, my bad.
next time I tell you, don't ISS.
It's not that too.
So if there is a coefficient in it, you can automatically assume it's balanced, okay? So the key, so today we've done number one before, okay? We have done number one before. The key thing to take out of this is an STP, okay? If it's at STP, your life is easy.
Quick question.
Yes.
I'm sorry. What is this?
This is number one. This is gas law stoichiometry.
What is that like? Is this like the base answer?
What?
Is this the base? But it's so completely different than gas flow. Okay.
We're combining the ideal gas law and stoichiometry.
Okay, that's not good.
All right, so this one is easier. This one is easier because it is at STP. Because we know how many liters is in 1 mole of a gas at STP. 22.414. So because it is at STP, we can just do a straight stoichiometry problem.
We're assuming there's excess oxygen.
What?
There's abundant oxygen. We're assuming.
Yes. So stoichiometry, I start with what I know. So I have 6.55 liters CH4 over 1. Okay. Times 22.414 on the bottom. 1 mole on the top. And 1 mole CH4 on the bottom. Where did I get this 1 mole CH4 from?
The balance equation.
Yeah, balance equation. What am I going to? Carbon dioxide. So 1 mole CO2 times 22.414 liters CO2 over 1 mole. Over 1 mole CO2.
Oh yeah, these are good. You might actually look at a lot of masses and stuff.
Well, this one you don't.
So I was your neck, your nose was weak. She was proud.
Okay. So that is number one. I mean, if you need a calculator to solve this one out,
I'm just gonna get it.
it's 6.55.
Honestly, I didn't even look at the money. That's my calculator. Yeah.
So we've done that before. We've done this numerous times, okay?
What is that, liters?
Liter CO2. 6.55 times 22.414 divided by.
So gas stoichiometry is what you're going to, and what you start with is the mole ratio is 1 to 1. It's always going to be the same.
But really, I mean, I would, if you're asking for work,
Steps,
yeah, if I'm just looking for work, I would be happy.
Yeah.
Liters to liters with that. Okay, I don't need those things there. There's no thing already going to cancel out. Okay. Now, the key thing in this, once again, was it was at STP. If it's at STP, you can do nothing but a stoichiometry problem. Okay. Let's do number 2.
This 273.15, right? No,
273 Kelvin.
no, because you ain't no decimal, so you just need.
But 273.15. It's whatever you want to say.
You do 115 or you don't, because there ain't no decimal places.
It depends. It depends if there's a decimal in the. If it's at STP, they will tell you it's actually like this. It's at STP. Okay.
Okay.
All right. So let's do number 2. The first thing you need to pick out.
You have to put what you know over.
No,
It's not a recipe.
it is not an STP. So if it is not an STP, you need to do an ideal gas law,
Okay, thank you.
and you can do an ideal gas law and a stoichiometry problem. Okay. So what I need to figure out, okay, so on number 2, it tells me how many grams of water are formed from 9.5 liters of oxygen at a pressure of 563 torr at 25 degrees Celsius. Is that at STP?
No.
No, it's not standard. Standard temperature is 0. Standard pressure is 760 torr or 1 ton. So in this, I need to do an ideal gas law problem. On this one, I need to do it first, okay? PV in RT. Do I know the pressure?
552.
I need that converted to atmosphere.
You will convert
What?
what's that chart?
Divide by 760.
You do that one for Tor and something else.
HG.
And then one of them is the same, but one of them is point.
0.74.
0.74.
0.741 if you need that.
I need that.
0.741.
You're thinking of KPA and PA.
Okay.
0.741. Okay, what's the volume?
That's
I'll give
That's
it.
18.
Okay.
What's the volume? 9.5. Now notice, this is 9.5 liters of O2. Here's the difference. Most people just want to do just a straight straight ideal gas law problem. This is oxygen. What's my answer want it to be in? Water, okay?
What's R? 1.8.
So T, moles is what I'm looking for.
Mo, that's a pop.
That's it, yeah.
They don't look like
That's
it's
it,
a
yeah.
pop source.
That's it. What's R?
You.
0.082057.
Oh, see, I was close.
Yeah, you said 1.
It's
And what about temperature?
gonna be 273.
298. In this case, I don't need the 0.15 because there's no decimals there. So I need to do my ideal gas law problem first in this one.
PV equals NRT.
What is one stand for?
So
Moles.
0.7 1 times 1 8. Hold up, it's 0.0802.
So someone tell me what X.
I know what you do. Hey, don't you gotta you times the left and divide by the right, or you
Times
divide
the left, so 0.741 times 9.5.
divide by the right.
Divided by.
All right, yeah. Nothing. No,
What?
start again.
That times that.
Divide that.
Divide that. Divide that.
I thought Justin had it.
I'll do that.
You never did look it up for him.
X equals 0.28. So
0.287
Yeah.
0.28.
8.
moles O2. I'm not finished, am I?
No.
Now I gotta do a stoichiometry problem. I couldn't do a stoichiometry problem because it was not at STP. So I'm on 0.288 mole O2 over 1 mole O2. Oh, so hold on. How many moles O2 do I have? 2 moles O2. Where did I get that 2 from? The balanced equation, I'm going to water. 2 moles.
Yeah, it's 2 water too.
Yep, 2 water.
And you going to what you going to grams?
Grams.
And grams are going up. Yeah.
That's molar mass of water.
Time.
So really it's just 0.288 times 18. So it's going to be right around 5.18.
I almost done with this intro.
So that's for right. That's right.
What?
So that's for right. Gram ratio.
Yep.
Yeah. How many liters of carbon dioxide, CO2? The pressure, is not a standard pressure of the same thing?
Does it say STP?
No, it said 18. No, I just told you it don't say.
Yes. I was reaffirming your statement.
You said like.
I was reaffirming your statement.
Okay. All right. So I know what to do then. So and it's already at 18. So 20. Hold up. Hey, which one will you?
No, I'm waiting for somebody to tell you the answer.
No. It's,
You said what?
we're using 8.2 or
What?
1.25.
The 7 parentheses, it shouldn't be there.
Okay, should it?
No.
So that ain't good. Okay. So we don't know the volume. That's what we're looking for. And then N. I don't know what it is. R is 0. No, 0.02
Now we gotta use the one with mold and all
The
that.
temperature, so you gotta do 42 plus 270.
Now, let me ask this question. On the last one, we did the ideal gas law problem first, correct?
Mm-hmm.
Because we were given liters.
Yeah.
On this one, we're going to do stoichiometry first, and then ideal gas law, okay? That's the difference in the two problems. That's the difference in the two problems.
I showed that I ain't got something.
So, I'm still not quite figured something out, though.
But you know, yeah, on the mode.
I'm sorry, you do need the stuff in parentheses.
After I scribbled it out.
You do need the
That's
stuff
what
in
confused
parentheses.
me. I didn't think we was gonna say that.
See, y'all-
Why do you need the stuff in parentheses?
They're
For
gonna,
the leaders.
Because you don't know how many moles you have, do you? That's why I'm lost, okay? That's why I'm lost. This is hard as it's going to get. So I'm going to use my stuff in parentheses. So I know that the pressure is 1.25 times the volume, which is 6.25, equals X times 0.082057 times, what's that? 85, so what's that? 250, what, 258, 358?
I don't know.
I think it's 358. Is that correct? So what's my number of moles?
time for us, I about for the
I got 26.6.
Everybody agree with that?
No, let me do it.
Yeah. I got 0.26.
Yeah,
Okay, that's
point
what
two
I
six,
got.
well, 0.27.
93 second figures.
Okay, so 0.266. 66, yeah.
So there are 0.266 moles
And what?
No, we.
He said methane and oxygen add together.
Of
What?
CH4 and
Yeah, I thought you said oxygen add together.
O2. Now, the problem gives you a key piece of information.
What, the add together part? What?
I mean, yeah, you've already got that
The
part.
same
They have the same amount. So how many moles of CH4 and how many moles of O2 do I have?
Divided by two.
So that means I have 0.133 mole CH4 and 0.133 mole O2. Because so we have the same amount, okay? Now we got one more thing you got to figure out first.
Where is she going? You know everything.
I don't know, I know something, but I got to think about something. Justin, you were talking about this a while ago on the first problem.
Okay. Well, we gotta use these moles to find the moles of the other ones.
What's a linear reactant? Which one of these am I using?
We're going from oxygen to water.
So I need to figure out which one's the linear reactant first, don't I? Everyone agree with that?
Yeah,
So I need to go, what substance, not oxidation, what substance am I going to? What do I want to know about?
We wanna know.
Liters of carbon dioxide. So let's go to moles of carbon dioxide, okay?
So you see it's proof that it's only one.
So 1 mole CH4 on the bottom, and then 2 mole CO2 on the top, correct? Is that right? Yep. So that equals 0.266. And then my other one would be 2 moles O2 on the bottom, correct? That was just a simple stoichiometry problem, moles to moles. So which one am I working with? The 0.266 or the 0.133? 0.133. Because that's my limiting reaction, okay? So I don't need this. I do not need that. Now I've now found my moles of CH4, can't I? So I've done my stoichiometry problem, correct? So now I'm ready to do an ideal gas law problem. We did it to find the total number of moles, okay? Now we got to do another one to find, because we found, okay, let me back this up. We did an ideal gas law problem for the total number of reactants, okay? Now we need to do an ideal gas law problem, but we've done our stoichiometry problem to convert from reactants to products, okay? So now I need to do my ideal gas law problem with my product information.
How is that CH4?
Oh, it's supposed to be CO2.
Yeah, that's what I got. That's what I'm sitting here looking at.
CO2. Okay.
Otis, if you're in the building, please come to the office. Otis.
So we using the 8.2.
The stuff that they just made.
That had me confused, but that's okay. I get it now. Limiting bracket, we can only make 1.3 to 0.1.
Yes.
We can only use
This is as hard as this gets right here.
And do you still want us to use the same volume?
No, I'm looking for the volume, aren't I?
Okay.
I'm looking for the volume.
The end use the same end?
The N, the number I just got. Okay, so the N is 0.133. Okay, that's the number I just got. I know the pressure being 8.2. I know the volume is what I'm looking for. R is 0.082057.
57.
What's that? And what about T?
315.
315?
Yeah.
So I'm not going to work it out. Somebody's telling the answer.
I got 0.41. Or just 0.4.
Okay, cool.
TB was in our T.
How you do this? You just
So I'll work it. So 8.2 times X equals 0.133.
no, like tell me how you do it.
I'm going to work, I will. 0.082057 times 315. So multiply the right, divide the left. What'd you get?
0.42.
0.42.
If not that, then it would be.
I don't know. I don't have the
That's
answer.
the answer, but I don't know how many you can figure. You only need 2, right?
0.42 liters CO2. So keep in mind, the key thing to look at for is an STP, okay? STP means it's just a stoichiometry problem. That's the easiest way to do it, okay? And if they're two different, now if they're the same thing, if you're just cared about a reactant or a product, you do just an ideal gas law problem. But when you have something, an information about a reactant and information about a product, not an STP, you got to do both an ideal gas law and a stoichiometry. Okay. Number 4. Why don't you try to work number 4 out yourself real quick? Okay.
The conversion factor of PSI.
14.7. Why don't
Divide by 14.
you might need to write those milliliters too.
Ugh.
That mean you got time to say.
No.
Divide by 10.
Yes, ma'am. All right, let me let you work that out, and then we'll come together and do it ourselves.